Have you ever wondered how your phone can just pull up a contact in a split second? Or how a music app shuffles through literally thousands of songs without even breaking a sweat? Well, it all comes down to the secret organizational system that's running behind the scenes. And that secret system, that's exactly what we're going to unpack today. The world of data structures.
I mean, really think about it for a second. Your computer has thousands, maybe even millions of files. So when you hit search, it's not just randomly looking everywhere, right? No way. It has a method, it has a system. And that system is really the difference between a perfectly organized library and just a giant, messy pile of books on the floor.
So, before we can get into organizing our digital world, we really have to understand its most basic component. We've got to ask the question, what exactly is data?
Okay, so at its absolute core, data is just a raw value. Think of the number 28, or the name Alex, or maybe the word blue. By themselves, they don't really mean much of anything. They're kind of like the individual raw ingredients you have on your counter before you even start cooking. Now this is where we start to give that raw data some context. An entity is the thing our data is describing. So if our data points are Alex and 28, the entity could be a user. And this user entity has properties, right? Properties like name and age, which can then hold those values we were just talking about. And this is where it all comes together. When we combine our data with an entity, we suddenly get information. User Alex is 28 years old. All of a sudden, those raw, meaningless values are processed. They're meaningful. We can actually take action on this, maybe send a birthday notification or something. This is the transformation we're always looking for, turning raw data into actionable information.
All right, so now that we get what data is, how do computers actually classify it? Well, it turns out it all pretty much boils down to two fundamental families of data types.
The best way to think about it is like this. On one hand, you have your primitive types. These are the absolute basics, the fundamental Lego bricks that the computer understands right out of the box. And then on the other hand, you have non-primitive types. And these are the more complex creations, the spaceships and the castles that we, the programmers, build using those basic bricks. So what do these primitive types actually look like? Well, they're probably exactly what you'd expect. You've got integers for whole numbers, floats and doubles for all your decimals, characters for single letters, and of course booleans for a simple true or false. These are the fundamental atoms of our digital world. And what can we build with those atoms? We can build bigger things, kind of like molecules, right? These are our non-primitive data types. An array, for instance, is really just a collection of integers. A class could be a collection of characters, numbers, and booleans, all brought together to represent our user entity from before. We're essentially creating our own custom containers for our data. Okay, so we have our data, we've figured out how to categorize it, now what? This is the real aha moment. Now we build a home for it, a system to keep it all organized and easy to get to. And this is the data structure. So here's the formal textbook definition, but what does it really mean? It's simply the way we arrange our data. It's not the data itself, but the container and the rules for how that data goes into and comes out of the container. And trust me, the design of this arrangement, it's everything. I want you to imagine a library with millions of books, but they're all just thrown into one giant pile in the middle of the floor. Finding anything would be a nightmare, completely impossible. Well, data structures are the shelves. They're the card catalog. They are the Dewey Decimal System for our data. They create order out of what would otherwise be total chaos. So why do we go to all this trouble? Because this organization is what allows us to perform all these critical tasks and to do them efficiently. The right shelving system makes it incredibly fast to find a book, to add a new one, to remove an old one, or maybe list all the books by a certain author. It is all about speed and efficiency.
And just like there are different ways to build shelves in a library, data structures have different architectural styles. So let's take a look at the two main approaches.
So first up, we have linear structures. This is where data is arranged sequentially, just one thing after another. Think of a playlist or a queue for a printer. It's first in, first out. Or stacks, which are last in, first out, kind of like your browser's back button. Then, on the other hand, we have nonlinear structures, where data can have multiple connections. Trees are perfect for hierarchies, like a file system on your computer, while graphs can map these really complex webs, like a social network or airline routes. The choice between them, it depends entirely on the problem you're trying to solve. To make this super simple, just think of a linear structure as a conga line. That's it. Each person is connected to the one in front and the one behind. It's a simple sequential order.
It's really easy to follow from the beginning all the way to the end. And a nonlinear structure? Well, that's your family tree. One person can be connected to parents and siblings and children. It's a whole network of relationships, not just a simple line. And this is absolutely perfect for representing things like those social networks we talked about, or even the file folders on your computer.
Okay, so we've built our shelving system and we've organized all of our data. So what can we actually do with it all? Let's look at the common operations that really bring these structures to life.
These 6 actions are pretty much the fundamental things that all data structures support. We can traverse them, which just means visiting every single item, like applying a filter to every photo in an album. We search them to find one specific thing in milliseconds. And we're constantly inserting and deleting data, like adding a new contact or trashing an email. And then operations like sorting and merging, those are the backbone of everything from your social media feed to giant, complex database systems. Pretty much every app you use is just a clever combination of these 6 basic operations. You see, in the end, data structures aren't just some abstract topic for programmers. They're a reflection of how we bring order to the world around us, from our contacts to our files to even our thoughts. They provide the framework that turns all that raw data into powerful, usable information. So the real question isn't just about code. It's about what you're trying to build and which one of these structures is going to be the one to bring your creation to life.